How strange. The absolute value of something divided by that same thing. Okay, well, if we're talking about dividing a number by itself, we usually get the answer 1. And we would get 1 if we had, say, a positive divided by a positive. But the fact that we've got absolute value means that, well, what's up there could have actually been a negative. Of course, the absolute value of the numerator would make it positive, but the bottom would still be a negative. Now, I know I could be proper. Let me give it a try. That is, we could have the opposite of x minus 4 divided by x minus 4 if the number was actually smaller than 4. That would give us a negative 1 for anything where x is less than 4. But it could be instead that you've got one number divided by itself. That would give you positive 1 for all the x values that are bigger than 4. Now, we shouldn't have exactly 4 because that's a domain restriction. You can't let the bottom be 0. Say I wanted to actually consider some values around 4, not exactly 4. Normally I would get real close, say 4.1, 4.01, 4.001, but I'm feeling lazy, keep it simple, stupid. Let's say I choose 5, 6, and 7, and some numbers smaller, not 3.9 or 3.99, 3.999. If I plug a 5 into that question, well, I've got 1 divided by 1. That'll give me just 1. If we plug a 6 in, we get 1. If we plug a 7 in, you have 3 divided by 3, which is also 1. If you plug a 3 into the top, that gives us the absolute value of negative 1, which is 1, but the bottom is negative 1, and that does make negative 1. It's the same thing we get as if we plug in a 2 or a 1. Just for fun, let's show it. If we plug that 1 in, 1 take away 4, absolute value over 1 minus 4. Absolute value of negative 3 divided by negative 3. That's 3 divided by negative 3. It is negative 1. Just for fun, let's check it out on a lazy graph. We knew something was up at 4. We weren't supposed to do that. When we plugged 7 in, we got 1. When we plugged 6 in, we got 1. We plugged 5 in, it made 1. We weren't really supposed to go to 4. We could get really close. Can't actually go there, so we'll use an open circle. Okay, when we plugged in 1, we got negative 1. Plugged in 2, same thing. 3, same thing. We were supposed to get close to 4, but not actually go there. Technical difficulties. Help a girl to plot a point. Get close to that 4, don't touch it. Aha! Now, this graph is not continuous. We do have a break. It appears that we have discontinuity at x equals 4. And the type of discontinuity we see is a gap. Since it's a gap, we say that's non-removable. Done.